Many times, we'll add devices to our projects for which the standard pop-up does not display all the data we want to see. In these situations, we need to create our own custom pop-ups. I'm going to build my new graphic based on the standard, but the procedure is the same if you're creating a new pop-up from scratch. Selecting the meter component we configured last time, the link here navigates to a page the same way our navigation buttons did on the floor plan pages. However, the bar symbol indicates this page is located in another project, namely PLS Include. To use this as our base, let's copy this page into our folder. I'll use the Open dialog to navigate up to the user folder, then down into PLS Include. This project has a TGML folder of its own, so I'll follow that down to grab my generic pop-up page and copy it into a pop-ups folder of my own. Remember that if every page in a folder is hidden with an exclamation point, the folder is also hidden in the menu. Let's rename this page to powerpopup.tgml and open it. The substitutions on this page are a little complex, so let's step back and drop a single new value on this page just to see how it works. I'll drop a text object for my total real power, then resize it and change the alignment. Now, just as with the simple real-time values, I'll create a binding for the content and paste in the value from the device I intend to use. However, this isn't exactly what I want. I need the text to be bound to the equipment that I filled out in the component that I click on. To do this, I'll replace the equipment part of the name with %, name, %. Technically, I could use any text here, but let's stick with name for consistency. Before I leave, I still need to change the format to presentation to view the data correctly. You can probably guess how this works. At runtime, when I click on a component on my main page, the script in the pop-up snippet takes the equipment name from the component, which we configured, and substitutes it for the string with the % before binding the component. At that point, it looks like any other binding. Let me go back to the one-line diagram to demonstrate how this works. I'll add the pop-up snippet, but I'll change the link to point to my new diagram. The component is already bound to my meter, so let's check this in runtime. As you can see, the new value is bound on the new meter. In most cases, this is enough information to create your own pop-up pages. You can take some time to add labels, formatting, and animations as though you were working on a normal diagram. That said, let's quickly see how these default values work and why I didn't tell you to just change their bindings. Each value block component has a text for the label, text for the value, and a binding that provides the runtime value. As you would expect, the binding engine replaces the component's name with the equipment name, then replaces the bind with the value. However, rather than binding directly to the text content the way we've done, this script performs some validation first. If the binding fails, the script hides the component away, which we've seen in the Web HMI. If it succeeds, it fills out the content of this specific text object with the value. I don't want to steer you away from this method. I just wanted to show you that there's more to modifying these than just changing a bind name, and this probably isn't necessary for most of your pop-ups. That should get you started building pop-up pages, which allow you to make detailed information available without cluttering up your main diagrams. Next, we'll see how to control our project from the diagrams. Until then, thank you.